Welcome back everyone. In our previous tutorial we have discussed how we can compare different algorithms. We have seen how running time is expressed as a function of input size. So now we are going to define what is rate of growth. Rate of growth is a rate at which running time increases with respect to input size. So to understand this thing, we'll take an example, and let us take an example of searching an element in an array. Here the number of input size is 6 and our aim is to search an element in the array. So you can write an algorithm for this. Let us suppose the function name is search. It takes an integer array, number of elements, and the element we are going to search. What we can do, we can run a loop for the full length of an array and can start comparing each element of an array with key, and if array element is equal to key, that means element is found and we can return the index. That element is found at this index. Otherwise we can return -1, which indicates that element is not found. Now let us analyze this thing. There is one case when key element is 2, and when you start searching you find this key element at the first location, and in this case the number of comparisons is 1. But what if your key element is 1? The number of comparisons will be 1, 2 and 3. And what if your key element is 5? The number of comparisons will be 5. This is because first time it will compare the key element to 2, then 3, 1, 6 and 5. And here we have written, this is written wrongly, 5, 6. Actually the number of elements are 5 and input size we can say it's 5. So in computer science, when it takes only one comparison or element is found at the first location, this is called best case. That means in best case we will have this much of comparison, we can't go below this, and this is called worst case. There is one another example for worst case. Let us suppose you take a key element as 10 and you start searching from here. So it is not found at this location, and even at the end. So that means you have made 5 comparisons and element is not found. So if you see these number of comparisons, you can see that here running time is a function of input size and we denote it like O of n. That means in the worst case, this capital or big O shows that it is worst case, and this n shows that these are at most n comparisons, right? So this means when we have an input size 5, the maximum comparisons we can have here is 5. But what if we have number of elements equal to 20. So of course, if you see the algorithm, in the worst case the number of comparison could be 20. And here we see that how our running time is increasing with respect to input size. There is one more thing, let us write it here. When we are talking about best case, we can also write it like O1, and this is called constant time. And when we are writing ON, this is called linear time, and that's why this searching algorithm is called linear search. We'll study more searching algorithms in our course, but I think this is fine for this lecture, and we'll continue in next lecture. Thank you so much.